Welcome to the class of Microwave Radar Engineering. The subject code is KEC074 and we'll start with the lecture number 7, and today's topic is the waveguide, and this is the second part of the waveguide. In the lecture number 6 we have started the waveguide section. Now we'll start with the fundamentals of waveguide here, and the pedal plate waveguide, pedal plane waveguide, and the rectangular waveguide. Now, what are the basics of waveguide? At microwave frequency, the transmission of electromagnetic energy. At microwave frequency, transmission of electromagnetic energy along a transmission line and coaxial cable becomes difficult due to high dielectric losses and the skin effect. Means at high frequency, the transmission line, the signal transmitted from the transmission line, it's difficult to transmit the signal through the transmission line due to the high dielectric losses and conductor losses. That's why we have introduced, or scientists have introduced, the another way of transmitting the microwave signal, that is the waveguide. And this waveguide is a metallic tube that can be used to transmit the electromagnetic power at the microwave frequencies. And this is made up of what? These waveguides are made up of copper or aluminium or brass. So first, basics of what is the parallel plane waveguide. In this two plate, one plate is this one and another plate in these two planes are parallelly. That's why if I say this is one plate and this one is the second plate, and the distance between the two plates can be known as A, and so the plate are infinite in one direction. These plates can be infinite in one direction. That's why if I say that is in the y direction, separated by, and the finite distance, that is separated by a distance A in the y direction. Clear? Actually, is this in y direction and this one is in x direction. So the direction of propagation is in the z direction. The direction of propagation will be is in the z direction. Clear? Now we have already studied about the Maxwell's equation. Del dot D is equal to rho, and second Maxwell equation is the first Maxwell equation, del cross E equal to minus del B by del T. The second Maxwell equation is the del cross H is equal to J plus में del D by del T, and the third Maxwell equation is the del dot D equals to rho, and fourth one is the del dot B equal to 0, and this are known as the also known as the Gauss law. Now while we'll study about the waveguide, before study about the waveguide, we should know about the longitudinal fields and the transverse field. What is longitudinal field? Longitudinal fields are the fields which exist in parallel to the direction of propagation. Clear? And the field which exists perpendicular to the direction of propagation, that fields are known as the transverse field. Clear? Now if I say, if I say this is the direction of propagation z, so field in perpendicular to the z direction, or that is Ex, electric field in the x direction, electric field in the y direction, and magnetic field in the x direction, magnetic field in the y direction. These are field are known as the transverse field. And longitudinal field is what? The field which exists in the direction of propagation, that is known as the longitudinal field, that is Ez or Hz. At higher frequency we always consider the fields in terms of electric and magnetic field. Now see, now let's say if I say transverse field, now we will first find out the transverse field equation, in which we will find out the wave equation and Ex, Hx, Hy, Ey in terms of Ez. Clear? Now let's say the wave is propagating in the z direction. If I say that the wave is propagating in the z direction, so the wave equation for TE and TM mode, the wave equation for TE and TM mode is this one and this one. What is TE mode and what is TM mode? Now TE mode is known as the transverse electric field. Now if I say this is transverse electric field, it means if I say the wave is propagating in the z direction, it means the transverse means there will be no longitudinal field. It means Ez is equal to 0 and clear, and Ex and Ey will exist, and also Hz is not equal to 0. Hz is not equal to 0. Clear? So this one is the TE field. What is TM field? TM field is the field in which transverse magnetic field is 0, means Hz equal to 0. Clear? And if I say TEM mode, what is TM mode? In which Ez and Hz both are equal to 0. Now clear? Not clear? Now see what is TE mode. TE mode is the mode in which the electric field is present in the x and y direction or perpendicular to the direction of propagation, and in which, and for the TM mode, in which the electric field, magnetic field is present in magnetic field present in the perpendicular to the direction of propagation. So the wave equation for TE and TM mode is equal to, for the TE mode, mean del square Hz equal to minus of omega square mu into Hz. This is the wave equation which we have derived in the last lecture. And why this is Hz? Because in the TE mode Ez is equal to 0, that's why I have taken it is Z, Hz. Magnetic field will be present in the z direction. And for the TM mode, Hz equal to 0, it means there will be del square Ez equal to minus of omega square mu into epsilon Hz. Now see, expand this equation and expand this Ez equation in rectangular coordinate system. On expanding del square Ez, that will become del square Ez, that becomes into, expand into this one, del square Ez upon my del square x square, del square Ez by del y square plus del square Ez by del z square equal to minus of omega square mu into my Ez. Now if I say, since the wave is propagated in the z direction, let's say the propagation constant, means del square by del z square, if I say that is equal to what? Square of propagation, it is gamma square. Clear? Now see, on putting the operator del by del square by del z equal to gamma square, the equation will become this one. Now see, take this equation from this side, you will get this one, and this is, now let's say if I say this is term as a constant, it is h square. This will also be what the propagation, this one is propagation, this one is also propagation constant. The overall h square will also be a what? Propagation constant. Clear? Now similarly, we can write this one for TE mode. it will be del square hz equal to del x square plus min del square hz plus min del square y square plus min h square into hz equal to 0. Now we have find out the hz. Now we will find out the ex, ey, hx, hy in terms of ez and hz. Now how we will find out the, first we will calculate what? We will calculate the del cross E, and using the Maxwell equation we will just putting the value in another equation, you will get the equation. Now see this one, how from first Maxwell equation I can see that del cross H vector is equal to j omega epsilon to j omega epsilon capital E. Now on expanding this equation, on having this equation, this one equal to this one j omega E, this E vector is represented in the rectangular coordinate, that is I cap Ex plus में j cap Ey. On solving this equation, just put this value, and when I have say that del by del square equal to gamma square, it means del by del z as the wave propagate. Let's say if I say the wave is propagating in the plus z direction, so del by del z is equal to minus of gamma. Put this value minus of gamma on solving this equation, and this one, and equate the x and y in from both the direction, you will get del hz by del y equal to plus में gamma hy equal to minus of j equal to j omega epsilon ex. Second equation will be this one. How you will see that this one, let's say if I say from this equation, you will see that I cap equal to del hz by del y minus of plus of gamma hy, and this will be equation equal to what? J omega epsilon ex I cap. Clear? Similarly, we will do the j cap, and similarly we will do the k cap. On equating this I cap equation from left hand, you will get this equation. Clearly, similarly from j cap you will get this equation. Similarly on equating the k cap from left hand to the right hand side, you will get this equation. Now see this one. In this equation, hz is present here, and but hy and hx is also present. Now we will put the hy value of hy and hx in this equation, so that it will come out to be the only terms of the hz. Only will get the term of hz only. So now you will use the second Maxwell equation, in which del cross E vector is equal to what? Minus of j omega mu into my H vector. Just put this value del by z equal to, similarly on solving this cross matrix equation and equating the I cap from both sides, j cap and k cap from both sides, you will get net these two equations, these three equations. Now see this one, hx will be what? Now if I say this hx will be equal to what? This hx equal to 1 upon me minus of j omega mu bracket start del of Ez by del y plus me gamma Ey. Now this, putting this value hx, and you will get similarly you will get the value of hy, and similarly you will get the value of ex. On putting this value equation of hx and hy in these equation, so you will get what? This one is what? Hy. On substitute this equation number 6, and equation number 6 is what? This. Put the value of hy here, and when you will put this value of hy here, you will get this one, and on solving this equation, जो omega mu को multiply किए both side, you will get, ultimately you will get this equation, and this equation is what, equal to what, h square, as we have all told you in the starting. Now you will get Ex comes out to be this one, and similarly we will get the, similarly we will find out the value of Hx, and this Hx value is, will put in equation number 7 here. Put the value of Hx in equation number 7, you will get H, you will get this equation, means you will get Ex. Clear? Similarly, you will get the Ey equation, sorry. Clear? Now Ex, as we have got the Ex and Ey, similarly we will get the value of Hx. Similarly we will solve the, now we will do, how can we calculate the Hx and Hy using second Maxwell equation, and put the value of equation from equation number 6 to into equation number 10 and 11. You will get, similarly Hx will be this one and Hy will be this one. Now see, now these, see these all terms are in terms of Ez, Ez, Hz, Z in the Z direction, Ez, Ez, Hz, Ez. Now Ex, Ehy are all are in terms of Ez and Hz only. Now see, now the here question that comes, why we say that, always say the waveguide, in the waveguide, in waveguide TEM mode does not exist. Why? So because in TEM mode Ez is equal to 0 and Hz is equal to 0. Now we will put Ez and Hz equal to 0. Put the value of Ez equal to 0 here, Hz equal to 0 here. Put the value of Ez equal to 0, Hz equal to 0. So you will get Ex, there will be no existence of Ex, Ey, Hx and Hy. And when there will be no existence of Ex, Ey, Hx, Hy, and already Ez and Hz is equal to, means all fields will be vanish. That's why we can say that, that's why we always say that the, this waveguide does not support the TEM mode. Clear? So the here question always come, why drive the equation for finding out which supports that the wave, that the waveguide does not support the TEM mode. Now see, these are the waveguide equations. Next we will find out for the TEM mode and TE mode, we will find out the value of Ex and Ey, Hx and Hy. Clear? Now see, for the TEM mode, del square Ez, del square E equal to omega square mu into epsilon E, epsilon multiply में E equal to 0. Expand this equation in terms of, expand this equation in terms of X, this equation in terms of Y, and this equation in terms of Z. Clear? Now on equation, this terms in X direction will be this one, Y direction and Z direction. Clear? Similarly for the TE mode, this one, expand this terms of Z X direction, Y Z direction, Z direction. Clear? And these equations are known as the waveguide equations or wave equations of, or you can say Helmholtz equations. Now see, we will do the analysis. We'll start with the analysis of rectangular waveguide. What is rectangular waveguide? In this, two metallic plates are here, and this waveguide is in the shape of cuboid. and this is the shows the length of the waveguide. Clear? Now let's say this one the length of width of waveguide A, and this one is the length of the waveguide B, and we always prefer that the A is always greater than the B. Clear? Now see, this one is the wave equation. As we know that del square E equal to plus में k square E equal to 0, this k square is equal to what? Omega square mu into में epsilon. Now expand this equation in terms of z. Therefore del square Ex upon में del x square, del square Ez upon में del y square, del square Ez upon में del z square equal to plus में omega square mu into में epsilon E into में capital Ez multiply equal to 0. Now let's say if I say the solution of this equation, is purely in terms of as a function of x multiply में as a function of y multiply में z, x y z, and where x y and z are the pure functions of x y z respectively. Clear? Now similarly put this equation here. Now when you will put this equation, you will get that del square x y z put this value here, del square plus में similarly put this value Now see, this one is a derivative of x, so this one act as a constant, and from this equation you will say x and z is act as a constant, and you will see that this one will become equal to yz plus में xz प्लस में एक्स वाई इज इक्वल टू प्लस में दिस इक्वेशन के स्क्वायर, ठीक है, प्लस में के इंटू में एक्स वाई जेड इक्वल टू 0. नाउ डिवाइड दिस whole equation by x y z. When you divide this whole equation by x y z, you will get this equation equal to 1 by x equal to del square x by x square प्लस में 1 by y del square y by del y square प्लस में 1 by z del प्लस में प्लस व्हाट, प्लस में ओमेगा स्क्वायर म्यू इंटू में एप्सिलॉन इक्वल टू 0. क्लियर? तो यू विल गेट this equation x dash by x plus में y dash double ted plus p equal to 0. Clear? Now see, assume let's say the solution of this equation, individual solution of this equation will be equal to minus of b square x, and equation of this individual solution will equal to minus of a square y, and similarly this one will be your h square. Now on solving this equation, x will comes out to be, on solving this equation, so let's say solution will be the solution of this equation, this is what, partial differential equation, and this one is also partial differential equation, this one is also partial differential equation. On solving this partial differential equation will be, therefore x will comes out to be c1 equal to cos of bxx plus में c2 cosine of bxx, y equal to c3 cos of ay into में y plus में c4 sin of ay into में y plus में equal to z equal to c5 c6 e के minus comma z. Clear? Now what are c1 c2 c3 c4 c5 c6 are the constants while we will calculating the so finding the solutions of this partial differential equation. Clear? Now see, put the value of here x, y and z. Clear? As the wave propagates along the z direction, so c5 will be equal to 0. Clear? Now when you put the c5 equal to 0, you will get Ez equal to this one and Hz equal to this one. Now see, as we know that we have already derived out that these four equations Ex, Ey, Hx, Hy, which are these equations. Now put the value of Ez and Hz in the every equation. Clear? On putting the value of every equation, Hz comes out to be 0, Ez comes out to be 0, therefore all fields will vanish. And for the TM mode, as for the TM mode, we know that the Hz is equal to 0 but Ez is not equal to 0. Now these are the what? Constants A1, B1, A2, B2, A3, B3, A4, B4. So these constants will be find out when we will put the some conditions. And how we will put the some condition? We will put the boundary equation for this one. Now see, on equating this equation, let's say first boundary equation at the bottom side, in which you will see that the Ez is equal to 0 at y equal to 0, when direction of y is equal to 0, and y x vary from what, 0 to a. Okay? Now Ez equal to 0, electric field at z direction is equal to 0 at the wall, this wall. Clear? And where y equal to 0, throughout this wall y equal to 0 and x is vary from 0 to a. Clear? Second boundary condition will be this one along this wall, when y varies from 0 to b and x equal to 0. So Ez equal to 0. Third boundary condition is this one, and fourth boundary condition will be this one. Clear? Now on putting the first boundary condition, as we know Ez equal to this one, this Ez equal to 0, put the first boundary condition equal to this one. Clear? Now we will put the first boundary condition Ez equal to 0, and at the first boundary condition what? Y equal to 0. Y is 0. When you will put this here y equal to 0, what? When you will put this y equal to 0, cos y equal to 1, only C3 will be remaining and this whole term will be equal to 0. Now see this whole equation will be equal to 0. It means you will see that this cos plus my sine can never be equal to 0, therefore this term is cannot be equal to 0, that means I can say that the C3 equal to 0. The whole term will reduces to what? Remove this equation, you will get equal to this one. Now put the second boundary condition. On putting the second boundary condition, z equal to 0 at x equal to 0 for y vary from 0 to b. Yeah, now see this, y will vary from 0 to b and x equal to 0. So this term will be 0, c1 cos bx into my c4 sin ayy. Clear? Now see, this term can never be 0. Clear? This term can never be 0. So therefore I can say that the c4 is equal to, c4 is not equal to 0. Therefore I can say the c1 equal to 0. Clear? Clear? Why I can say that the c4 is cannot be equal to 0? See why I am saying that c4 is not equal to, that is all due to the, we are putting the second boundary equation. Clear? So therefore Ez comes out to be c2 into my c4 sine of bx into my x into my sine of ay into my y. Now see the, upon applying the third boundary condition, z equal to 0, y equal to b, x equal to 0. On putting this second boundary condition, you will get the third boundary condition, you will get the sine of ay by equal to 0. Therefore ay comes out to be n pi by b. And similarly, on putting the fourth boundary condition, when z equal to 0 and these are the equation. Now see that this equation comes out to be 0. Now put this one, we will get bx. So overall equation will be equal to this one. Overall equation equal to this one, and where c2 and c4 are the constant, so overall constant will be equal to is what? C. So therefore Ez equal to this one equation. Now put the value of Ez in the Ex equation. Put the value of Ez in this equation, Ez, and as we know that the Hz equal to 0, put the value here, Ez. On putting the value, you will get Ex comes out to be this one. Clear? And similarly for Ey, put the value of Hz equal to 0, put the value of Ez here, and you will get Ey comes out to be this equation. Clear? Similarly, Hx is this one, and Hy, Hx, put the value of Hz equal to 0, Ez की value put कीजिए, you will get Hx in Tm mode, and the overall general equation for the Tm mode will come out to be Ez equal to E naught sine of n pi by x, n pi by a x into my sine of n pi by b into my y e q r minus gamma z. You will see that this is the general equation. On putting this value, you will get Ey and Hy. Clear? Now see Ex, Hx, Ey, Hy, these are the overall equation. Now you will see, put the value of m equal to 0 and n equal to 0, means Tm equal to 0, 0. Put this value here. Now we will see that the Ex comes out to be 0, Ey comes out to be 0, Hx comes out to be 0, and all are comes out to be 0. That's why I can say that these are the non-propagating modes which cannot propagate inside the volume. Okay? Now similarly Tm m0, if I put the n equal to 0 and any of the equation all comes out to be 0, m comes out to be 0, means these are the modes which will not propagate inside the volume, and only Tm Mn modes will propagate when m is greater than 0 or equal to 0 and n equal to 0. So for Tm11 is the lowest mode which propagate inside the volume, inside the rectangular waveguide. The book I have referred for preparing the slides, that is Microwave Devices and Circuits SM Lab. Thank you.